And welcome to the Daily Space Weather. It has been a chill past 24 hours on the closest star. We'll tell you all about it here at the Smash News Network, least busted name in news. Thanks for tuning in to the Daily Space Weather, the most comprehensive daily space weather and detailed imagery you'll find in the known universe of the closest star. That's the past 24 hours from SDO in ionized iron, 171 angstroms. It depicts the lower corona. You can see some more activity there rising in the east. There was an M-class flare. We'll tell you all about it. There is a CME propagating and a huge filamentary reorientation happening in the eastern limb as we speak. So here's the SDO intensity gram, the Solar Dynamics Observatory. That is yesterday plus today, July 21st and July 22nd to date. Most of those groups stable over the past 24 hours. There is a very interesting group in the southeastern limb, way down here at a very, very high latitude there. An interesting sunspot indeed. It ought to get a name today. It's been there for more than 24 hours at this point. Again, a general dip in solar activity. There was at least one significant solar flare, which we will cover. Before we continue on with that, let's take a look at what's going on planet Earth. There are indeed some volcanic eruptions happening, like this one on Iceland. Some new real estate being made there. Now we've got two lava flows instead of one. It looks like two active lava flows certainly there. And they're both headed in the same direction there as new real estate is born in southwestern Iceland. Let's see what else is erupting. Abiko has been producing a 15,000-foot plume of volcanic ash. Please do not pole vault the caldera. It could be unhealthful. And we need the views on YouTube. Also, Subanosejima is erupting, producing a 7,000-foot ash plume. Mount Mayan, unknown volcanic ash plume size there. Please do not pole vault that caldera either. Located on Luzon Island, Philippines. It's been quite active in the past couple of weeks. Karengatang now back on the list as it explodes. 8,000-foot ash plume there, flight level 080. And Ibu exploding as well on the Isle of Halmahera, Indonesia. Frequent Vulcanian-sized eruptions take place from the cinder cone within the summit caldera. Semeru also exploding, flight level 140. Popocatépetl exploding, flight level 190. It's a 19,000-foot ash plume over central Mexico. Santiaguito, no volcanic emissions in Guatemala from it. Fuego, however, exploding, flight level 190. Continuous emissions in Peru from Sabancaya. And continuous emissions as Ubinas explodes in Peru as well. Flight level 220. It's a 22,000-foot plume of volcanic ash. Once again, please do not pole vault the caldera. Here's what's going on in terms of seismic activity. It's been very calm here over the past 24 hours. Only one quake of a 5+ magnitude. And it occurred at Tonga. So here is the 24-hour list from USGS. That 5.5 at Tonga occurred at 19:01 Universal Time yesterday evening. 5.5 magnitude at Tonga. Estimated depth there, 11.3 kilometers. Besides that, again, no 5 or greater magnitude earthquakes at all for the past 24 hours. So very calm in terms of earthquake activity. Just keep in mind that any earthquake can be a foreshock, and that we often see a statistical calm before the storm, as it's pretty tough to forecast earthquakes. If we figure out how to do it, we'll let you know. 10.7 centimeter radial flux is now all the way down to 174 as we get back to space weather stats. The 10.7 centimeter radial flux comes from the upper chromosphere and lower corona, right about where my pointer is. And it's super important to solar activity. There is the 1-year graph of the radial flux depicted by the black line. That is from solon.info/solar. Solon.info/solar. And welcome to the world of the living, Smash staff. Next, looking at the Space Weather Enthusiast dashboard. And NOAA's actually forecasting a little uptick in activity here. It looks like a coronal hole high-speed stream to me, but there is no explanation of what it is on their forecast model. It looks like just a general uptick there in solar wind speed in the coming days. So that looks like a coronal hole high-speed stream. Here's what NOAA has to say. NOAA says, expecting geomagnetic unrest Monday night, July 24th. So Monday night we may see some auroral activity. Fingers crossed for that. Again, I suspect it's a coronal hole high-speed stream. And let's talk a little bit about Enlil spirals. Yeah, Enlil spirals. So we showed you the NOAA Enlil spiral, and I just wanted to explain the NASA Enlil spiral, as it is very, very different. So what we've done here is we've chosen inner planets and density. And what that'll do is that'll animate this situation right here. And what it's showing is, first of all, Solo over here, Mars. You've got Mercury. You've got Bepi Colombo. You've got the Parker Solar Probe. Here's Venus. There's Earth. There's Stereo A, and there's Osiris Rex. So what's important about this is that it shows you the three-dimensional interplanetary magnetic field line. So this is like the whole thing turned to the side. And this does show you the effects of impacts when they are actually modeled correctly. But this is giving you more information than the NOAA Enlil spiral, because it shows you those very important, those dotted lines there. That's the 3D interplanetary magnetic field line. So the areas where we have magnetic field data there, you can see the way that the plasma affects those magnetic field lines. This is a more detailed report than NOAA's Enlil spiral, which does not show that information. So if you go to the Space Weather Enthusiast dashboard, you'll see this, a completely different Enlil spiral that just depicts plasma density and radial velocity. The NASA one depicts the interplanetary magnetic field line. And then the current sheath, that is the sector boundary crossings. Of course, Earth has just moved into a new heliospheric current sheet, which we will cover here in a minute. So if you're not familiar with the Parker Solar Probe, there's a Wikipedia article about that if you like. Here is an image of the Parker Solar Probe. Fastest object ever built by mankind. Every time it does a new closer and closer solar orbit, it breaks a record. So the Parker Solar Probe, it's expected to travel as fast as 430,000 miles an hour, or 690 kilometers per hour, as it completes its mission in 2025. So Parker Solar Probe, it's giving us great information, and it's an interesting object indeed, named after Eugene Newman Parker, Professor Emeritus at University of Chicago. So here's what's going on in terms of Earth's magnetic moment from space. It's our Geospace Magnetosphere movie. Let me pull that back. This is the past 4 hours of magnetohydrodynamic pressure in the Earth system. Nothing major going on there. It's geomagnetically calm. We've got fairly homogeneous magnetohydrodynamic pressure on both the sun and the dark side of the planet. So calm conditions there for the past 4 hours. No major changes. Here's Earth's magnetic moment from the ground since we showed you it from space. Here are changes to Earth's B field from ground level. And there were some intensifications there. Likely some ability to see the aurora there in northeastern Canada recently in the past 4 hours. But things are overall quite calm. KP index currently at 2.33. KP 2.33 is the planetary K index, a global average of geomagnetism, and here is our real-time solar wind data. We did see a strengthening of the fields here for a minute, so there was a moment where it looked like we could get into major geomagnetic storm conditions, where we had a total field of 15 nanotesla and a BZ of negative 15. So that is the kind of thing that if that would have continued, that would have been a geomagnetic storm, even with those relatively modest solar wind density and pressures. Velocities. So, however, that did not continue. The field weakened, and the BZ went into positive territory. So, since then, it's been pretty nominal solar winds here, nothing too exciting going on. Current conditions are about 3 protons per cubic centimeter for the density, solar wind velocity about 430 kilometers per second. Ghost magnetometers here featured some very low readings for the past about 6 hours there. Or I'll say the last about 12 hours there. Quite low highs. And average lows. Also, the Ghost 16 and Ghost 18 had to maneuver there. That's what these arc jet moments are. Their thrusters create plasma, which can affect the magnetometer readings, and they show you it right there so that nobody claims that NASA is hiding data. Next, our top view ecliptic plane field plot. Again, Earth has recently moved into a North Pole current sheet, and we're going to see more and more sector boundary crossings coming here, because if you look at the latest image, you can see a South Pole current sheet right there. So Earth has just snapped into the North Pole current sheet, depicted here in green. South Pole current sheet coming as early as tomorrow here. So second sector boundary, and then another sector boundary, and then another sector boundary. And that's just a lot of South Pole oriented current sheet. The plasma that comes out of the sun is polar. It is oriented to one magnetic field or the other, north or south. Speaking of which, here is our line of sight field plot. This depicts the solar B field in blue. We showed you the Earth's B field. Here's the sun's B field. The B field being the field that goes through the magnet. It's sort of like the product of the two polar fields, and the way they overlap, it's like the net field. Solar polar fields depicted in green for north and red for south, which brings us to coronal holes. And you can expect to see more coronal holes coming in the next days. Here's our coronal hole line of sight plot. And we've got a solar disk here that features both north and south pole oriented coronal holes. Again, you can expect an uptick as the North Pole coronal hole has finally left the north heliographic pole, which opens the floodgates to solar cycle 25 maximum. So here are the past. That's yesterday plus today from SDO. Let's bring up the last image here. So at the moment, these are all South Pole oriented coronal holes, and down here we've got some North Pole oriented coronal holes. The sector boundary crossing is like this, and Earth is on this side of it in terms of magnetism. So that's what's going on for coronal holes. Again, there's the latest image. North Pole coronal holes in the southeast, and the rest of these are south. So south, 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 and these are north down here. Which brings us to sunspots. And by the way, thanks for tuning into the Smash News Network, least busted name in news. Please support the channel by pressing the like button, subscribe, share, etc. Dear NASA and NOAA and ESA and everybody else naming sunspots, name this sunspot. It is at an incredibly high latitude, very close to the polar region. We've got a huge spread of sunspots at the moment. That one down there ought to be called 3380. Besides that, no changes there to the sunspots. It has been steady as she goes in terms of sunspot progression. So let's take a look at some sunspots here. Let's break out our custom Helio Viewer videos. Here's a 24-hour video featuring 131 extremes, plus the SDO continuum there. Great at highlighting the active regions. You will see an M-class flare in the upper right. That was the most significant intensification. Here's a close-up of that sunspot group down in the southeastern limb. That ought to be a story. It's an indication that there is still a long way to go to get to solar maximum. There's a close-up of that sunspot group. Has degraded a little bit, but it certainly still has umbra. It's had umbra for more than 24 hours. It ought to be called 3380. Name that sunspot. Here's a full disk view in SDO intensitygram, or SDO continuum. And we do have quite a few large sunspots. And we still do have a large possibility of large solar flares, folks, because check it out. Still showing up here as between 39 and 61% chance of a large solar flare, and it is back here behind 3379. So that portion there is the part that has the deltas. This area back here is, as far as magnetic shear, the most likely place to produce a large solar flare. So here are the magnetograms. Let's see if we see any major changes happening there. I think it's more likely to see another large flare from up here as that group approaches the limb. So here's the full disk view with 131 plus SDO magnetogram. And that brings us to energetic particles and solar flares. So as far as solar energetic particle events, they have subsided. The ghost proton flux here back to baseline levels. And again, the largest solar flare in the past 24 was this M3, an M3 flare, or M2.98. We'll round that to M3. And there's an intensification happening right now. I believe it is from the eastern limb. We'll show you here in a minute. It looks like that is already leveling off there. It was only a C7 class flare, no big deal. There's the 3-day graph that we usually show. So here is SDO 94 plus 131 angstroms. And a great view of that M-class flare in the northwestern limb. And you can see a bit of that intensification happening in the eastern limb as well. It looks like there is a minor CME and a plasma reorientation happening there in the east. Next, we will move to a star chart. As before we talk about coronal mass ejections, we want people to be oriented. This is where things are above our head here in Lehigh Valley, Pennsylvania. This star chart from skyandtelescope.org. And if you're viewing the evening sky, go check out Venus and Mars, also a sliver moon up there. It's a great time to be viewing the post-sunset skies. You can also see Mercury if you have a low horizon and low light pollution. Next, a solar system forecast from theplanetstoday.com. This is where things are today. Here's where they'll be in 1 week. That's where they'll be on the 29th of July. And it's time to move to coronal mass ejections. So here are the data from George Mason. And it has been pretty chill. So there were some CMEs here. We do not anticipate these to be earthly directed coronal mass ejections. That is 94 frames from yesterday. And here come some more frames from today. There's a more interesting CME out of the western limb. Also does not appear to be earthly, or does not appear to have any earthly directed components there. It looks like it'll miss Earth to the west. So here's Soho, Lascaux C2 and C3. And there's that most recent CME. It looks like sort of a double pulse event. We'll also show the view from stereo A. Feel free to pause the video in this frame if you're not familiar with the locations of these objects. Stereo A here on the left. By the way, A stands for ahead. It's about to be behind, as Earth and stereo A are crossing each other's paths. So there's that CME coming out of the west. Again, it does not appear to be earthly directed. I don't see any real halo there. And we'll see if we can get a better bead on that in just a moment here. 722, there we go. There's a view from stereo A. Doesn't look like it's headed toward stereo A or toward Earth. If it were, it would be a pretty strong impact there. That looks like a pretty dense core in that CME. So here comes some custom. What happened? There we go. There are some custom views. That is a 24-hour video from SDO 193 angstroms, Lascaux C2 and C3. Here's a little closer zoom in. And it looks like that CME was indeed associated with that M-class flare in the northwestern limb. I'm not even sure if that CME came from the Earth side of the disk. It may have come from somewhere on the far side, as there is quite a bit of activity over there. You can see some kind of a pulse happening here from behind the solar disk. Of course, this doesn't really help with depth perception, as it is a 2D image here of a very bright object. Definitely not an Earth-directed coronal mass ejection there. So let's move to filaments next. And if you haven't joined us on Twitter, here's some incentive to join us on Twitter. We've named a filament. You might like the name or dislike the name, but right here, this filament right here needed a name. Nobody did it, so this morning we named it on Twitter. So if you want to name filaments after living humans, whether they're lizard people or not, join us over on Twitter and follow the hashtag Name That Filament. Of course, we don't see the tweets that we actually want to see on Twitter because the platform is completely broken, as censorship has been retained by big tech oligarch Elon Musk. His fanboys keep claiming that he's fixed free speech on the internet. It's pretty pathetic. One of the many cults of nonsense is the cult of Elon Musk. Anyway, we've named that filament after a living person. More on that in a moment. But that's the ground-based Hydrogen Alpha telescope at El Teide, Spain. We've got some more filaments down here, like this one could use a name as well. And there's another one here just rising. Also one here rising around the eastern equatorial region. So plenty of filaments to name. And here's a great view of filaments in, that's SDO 193 plus 304 angstroms. Showing great depth to the closest star's corona. Here's an even closer view. And you can expect to see additional CMEs by the time we make tomorrow's video. More coronal mass ejections. The likelihood of those remains at 100% in the next 24 hours. Anyway, that said, the sun will surprise you sometimes, so never assume, folks. You'll just make an ass out of you, but certainly not out of me. Anyway, here are the past couple of hours. What happened? Do I still exist? Do I still exist, folks? All right, I still exist. It's confirmed. Here are the past couple of hours from the GOES 18 SUVI, looking at ionized helium. And there's that CME and plasma reorientation happening over here. It's associated with that C-class flare as well, I think. I think so. And that brings us to bonus features. So first, satellite charging hazards. We do have some minor surface charging hazards there as low-energy electrons build up on the outside of those spacecraft north of the equator there, moving into the Central Pacific Ocean, currently in the East Pacific and western Mexico. The GOES electron flux here has cratered. Surprisingly low levels there. Keep in mind it is midnight local time for the GOES 16 and GOES 18, represented by these M's. That's midnight local time. These are noon local time for the satellites. And there's the one-year graph just in a low to moderate range there for the electron flux. There is the forecast model, NOAA expecting similar levels tomorrow. We'll also show the layer where it's measured. That would be the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with the information depicted. And here's the vibrational frequency of the bridge between Earth and space. The F ionosphere is located at about approximately 300 kilometers of altitude. And that is what's shaken diffuse gas at the bridge between Earth and space. Mostly ions, as it is exposed to ionizing radiation from the closest star and all of the rest of the ionizing radiation showing up from deep space. If it looks like Greek to you, we don't mind. Here's the anomalygram. depicting anomaly in megahertz from a 30-day median. And things are looking quite normal at the moment. There's the latest image, 11 o'clock universal time ionogram and 11 o'clock universal time anomalygram. Total electron content is free electrons to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with the data depicted here. And we've got some significant total electron content anomalies. It's the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. Your GPS satellite must communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere to get a signal to your handset. Too many free electrons cause signal refraction. We've got a lot of signal refraction here in the southern Indian Ocean, the Southern Ocean, Antarctica, south of Africa, and the southern Atlantic Ocean. So quite a few electrons here out of place. And this is more typical of those low electron flux numbers that we showed you earlier with the GOES electron flux. Those are the likely places for GPS errors. And we are seeing some electron content anomalies over the Caribbean as well, which we'll show next. And here's the anomaly from the 10-day average. And you can see right here, this island south of Cuba here, whatever island that is, showing a significant signal there for high electron content anomalies apart from the 10-day average. So perhaps another earthquake forecast showing up there. We are interested in seeing if pre-earthquake signals do show up in the space weather data. So we'll play that through and then let the whole run play through once again. Possible signal there indicating a possible 6+ magnitude earthquake south of Cuba within the next 4 days. So that's not really a forecast. That's just a possibility that there may be an Earth-generated signal there. We're not suggesting that the earthquakes are caused by the space weather, but that a signal is appearing in the space weather data generated on the Earth side of things. So that's interesting. There you go. Possible 6+ magnitude quake coming there somewhere in the Caribbean in the next 4 days. So far, these forecasts have not been accurate. We haven't seen a Cascadia large earthquake. So we'll close out the space weather portion of this video with the latest intensitygram seen here. And here's the latest colorized magnetogram. And that sunspot is degrading quickly. It might never get a name, folks. It should have gotten a name. It's been there for about 24 hours. I think it only needs to be there for 12 hours or more to actually get a name. Here's the full disk view. Whoopsie. There we go. There's the full disk view. And it looks like some degradation happening back here. Some minor deltas there. But looking pretty weak. Looking pretty weak. I think this area is still the most likely to produce a major flare. And there's a close-up of that. Quite a few magnetically complex groups here, really. I mean, that group there is magnetically complex. It is barely beta gamma delta class. That group is just large sunspots, not that magnetically complex, very symmetrical. Anyway, here's the full disk rock back once again. And before we go to meteorology, let's talk about social media. Are you on it? Have you unplugged entirely? If so, we don't blame you in the slightest. And if you go over on Twitter and follow us over there, I would have to say, decent, to quote a Bubbles from Trailer Park Boys. And yeah, we've named that filament. It's now known as the Cardi B solar filament. So you can find us all over social media, and you can find our links at smashomash.com. You can also hit us up on Instagram if you've got auroral imagery or meteorology stuff or anything like that. Instagram's a good place. You can send messages. Also on Twitter, of course. Links at the homepage at smashomash.com. And by the way, Welcome to the Neo Renaissance. Congratulations on realizing our channel exists. We're frankly surprised that you were able to with the ridiculous, nonsensical state of affairs, as many major international corporations completely shatter their own credibility. I'm not surprised if you've divested from certain organizations who will remain unnamed. But welcome to the Neo Renaissance. We launched our website in response to pathetic censorship from, again, an unnamed big tech organization. So visit us over there. Help us out by clicking our links. Press the share button on social media, etc. Thanks to everybody who has. Thanks especially to our Smash team members. More on that in a moment. First, let's do some meteorology stuff. Here is what's going on in terms of dust. Yeah, dust. Saharan dust has been tamping down this system, but it keeps moving closer and closer to North America. So it's gotten a little bit of a respite here as it's not sucking up as much dust as it has, so it's gotten into some more neutral territory here. And as far as ocean temperatures go, well, sea surface temperatures are pretty warm there. There is a bunch of warm water around it, and indeed anomalously warm water ahead of it. So I suspect that this thing is going to want to make a turn to the north a little bit. So it could start affecting Newfoundland here. So just so you are aware of that, to all of our Canadian viewers out there. Take off, eh, you hoofty? All right, so let's move to our regularly scheduled meteorology segment here. We want to talk about things like, am I good? All right, we're good. We want to talk about things like surface winds and jet streams. So here are the surface winds. Looks like a powerful low there affecting the Philippines. Also a strong low there south of Australia. Here are the jet streams of the eastern world, still blowing backward over the northern Indian Ocean. Here are the jet streams of the west. Fairly coherent jet stream over most of the U.S., save for the area around Arizona, where there is a high-pressure upper-level anticyclone right there. Surface winds depicted here. Surface winds of the central world right here. And let's don't forget the jet streams for Europe, Africa, and the Middle East. Jet stream also blowing east to west there over northern Africa and the Middle East. So a little bit of backward jet stream action there. It's not a super strong signal. Let's move on to the windy.com map. So that's what's going on. Let's see how this low is expected to move. I just forecasted it based only on ocean temperatures, folks. I suspect that will make a turn to the north. Let's see what happens. This is the Euro forecast. As you would expect the system to move toward the warmest water. And that's exactly what it's doing. Gee, is that a surprise? That's called understanding atmospheric physics. Next, this is the clouds and fog scenario for the Americas. It's too dark for the visible satellite, so we use the shortwave radiation map. Next, your smoke forecast. And dag, it looks like Winnipeg is getting pretty smoky. Winnipeg is getting kaplastered with some smoke there. Also, Northern California seeing some serious smoke, mainly around the Oregon border region with California. And let's show some additional forecasts, but first, the National Weather Service homepage. So there it is. There's the National Weather Service homepage. We've got, looks like, excessive heat advisories there around the Gulf Coast and Florida. Also some excessive heat warnings there in Arizona, southern Nevada, Utah, California, etc. Also eastern Montana, showing some extremely hot temperatures. Here come your forecasts. This is your GFS 72-hour jet stream forecast. Here is your 72-hour pressure and precipitation forecast. And here is your 72-hour temperature anomaly forecast in degrees Celsius. These are all the GFS model forecast. We show 3-day forecasts because they're accurate. If you're watching a YouTube channel who is showing you like 2-week forecasts, 4-day forecasts are highly inaccurate. Even 3-day forecasts in comparison to 1 or 2-day forecasts are highly inaccurate. 3 days is the limit. If anybody's forecasting the weather for the next 14 days or 14 years, take that with a truckload of salt. It's probably utter nonsense. Anyway, here's our lightning mapper. And there was some heavy lightning there across Georgia, especially in the past about 10 hours. And how about a real-time lightning map from lightningmaps.org? Lightningmaps.org. Next time you hear thunder, convince the natives that you're Zeus or Thor or perhaps a horror movie villain. Watch, here's how you do it. If you're here at Kosciuszko, you say, "It's only a matter of time before your souls are cast into an ever-deepening and darkening abyss." And then as you say abyss, the thunder rolls in right at that moment, and then people go, "Oh my God, I'm spooked. I'm spooked." Spook the natives by forecasting thunder using blitzertongue.org's lovely lightningmaps.org. If you enjoy the content, press like, subscribe, share, etc. Tell your friends and foes about us. If you want to support the channel, become a member of the Smash Team. Yeah, the Smash Team. SmashoMash.com/Smash Team is the official subscription services site of this channel. We replace Patreon with something superior, although we are still technically on Patreon. You can find a link to that on the homepage at SmashoMash.com. If you need to send an instant message, do it on Discord. Permanent invite link to the Discord channel right there. SmashoMash.com/Smash Team. These videos are brought to you at massive personal risk and expense by Smash staff and I, but also by the Gold and Silver Smash Team members. So, and if you're unable or unwilling to open your cobweb-encrusted wallet, you can even become a bronze member. You'll still get email alerts about things like disasters. If you're unwilling to do any of that, visit our sites or visit us on any other social media. Please press like, subscribe, share, and comment on YouTube. If you're an influencer, drop us a line. We'll consider coming on your channel. We're going to close out this space weather and earth weather video with U.S. Doppler radar, shortwave radiation, and water vapor. So here is the vertical motion in the air column. That's what your Doppler radar is depicting. It's depicting the vertical motion of snowflakes, water droplets, and ice crystals. And the more motion happens, the redder it gets on the thing, because that's how a Doppler radar works. It's measuring motion, vertical motion. So this is measuring infrared radiation from the satellite's perspective. The infrared radiation band here is 3.9 micrometers, part of the infrared spectrum, and here's 6.19 micrometers depicting water vapor. And it looks like clear skies are coming to Tennessee and Kentucky. Shout out to Julie. So that's what's going on. Here comes a recap. Doppler radar for the lower 48. Clouds and fog depicted by 3.9 micrometer infrared radiation, part of the NASA GOES interactive weather satellite suite. And there is the water vapor map once again. And once again, thanks for tuning into the Smash News Network, least busted name in news. With all of these spooky things happening in space, I've been convinced by utter charlatans and nonsense dealers on YouTube that I've got to head back to my bunker. So that's what I'm doing. While I'm gone, may that solar wind be at your back. And don't pole vault the caldera, folks. Don't pole vault the caldera, but do visit the links. See you soon. I'm going back to the bunker again. Whoa!